In this presentation, I am going to deal with a collision of a very common kind, yet to my mind one of the most fascinating kind. We have seen in the earlier presentation collision between two spherical balls of the same mass as in Newton's cradle, or two wooden discs of the same mass as in Newton's Carrom, and we found that the incoming ball transferred its entire energy to the outgoing ball. But today, this common kind of collision which we have watched since our childhood, that is the bouncing of a ball off the ground, whether in basketball or cricket. Here we have a ball bouncing off the ground, which is a giant spherical ball called the earth, and in what you see is that as I leave the ball, now I'm going to bounce these two balls. One is a basketball weighing over 700 grams, and other is a small, what you call springy ball, about 30 grams. As we drop them, you watch their rebounds and their return. If I drop this ball approximately 3 feet from the ground, watch its bouncing back. It bounces back nearly to the same height. It can never go above the height from which it came down. Similarly, look at this small ball. I'm going to drop it. It again bounces back to the same height, slightly less, because some energy is lost in the impact and in friction. Now I'm going to place this small ball weighing about 30 grams over this large basketball in this fashion and drop them together and watch. The explanation of this phenomena lies in the fact that the heavy ball, while bouncing off the earth and is returning back upwards, strikes the falling green ball. To the green ball, the heavy ball is like a massive earth, and it bounces back upwards with its relative velocity, which is now double, and that causes the ball to go much higher than what it was normally doing when it was dropped directly to the ground. This phenomena explains some of the spectacular shots played by cricket players. With an effortless swing of their bat, they are able to throw the ball far, far away. Thank you.